welcome to the talk. So this is one of those many profiling themed talks at this conference. There is considerable overlap, but I think I've happened upon an angle of it which is not discussed enough, and I need to work together with a bunch of other toolchain folks to bring it to full fruition, but not as much as you might think. So this is a gap that's sort of outside the tools. And it's probably not the first solution to this problem, but let's see the problem. So compilers, other tools have had profile-guided optimizations for a long, long time. There's LTO, there's a whole family of them. The problem that I am finding myself particularly impressed by is how little these things are used in practice. At least that's my impression. People are using them in some extreme cases. Companies that have, some companies have very important large binaries that they build internally, and then they turn on all the optimization that they can because they have full control, and they're not afraid of one-off sort of build jobs. But that leaves the rest of us. So we have no shortage of profiling tools. I list some more very shortly, but there are a great many. GCC and LVM have a multitude of functions to tune compilation, optimization, linking, and when these features are advertised, there's invariably some good news in terms of performance potential. It's not unusual for there to be 10-20%, sometimes at least held dangled as a possible win. So it's sort of annoying that we're not really taking full advantage of this. And so the sort of question I was asking myself is why not? And well, my suspicion is that it's more a tooling problem, an ease of use issue. And for companies that have their monolithic binaries and who can afford every bit of release engineering magic to overcome those tooling difficulties, that's great. But for some other contexts, that is just not possible. So let's try to make it possible for the rest of us too. I was hoping Jan would be here, partly because he gave 2 talks here about profiling and profile-directed optimization stuff. The AutoFD one was a nice talk that happened yesterday morning. There was one just before lunch too. So there's, again, a lot of effort going on. One aspect of difficulty is things like just choosing your favorite tool. There are so many of them. I think I would have to use a font about 10 times smaller to list every one of the profiling related tools out there. And they all exist for some good reason, not just to scratch someone's itch, but they actually had some kind of feature delta that someone needed. And some of them are larger than others. It's fine. One particularly annoying aspect of some of them is that they require special hardware. Modern CPUs have branch recording functions in hardware. Some have call stack recording hardware that profilers can use to extract or sample historical patterns at a very fine grain. And other hardware does not. And that's just how it is. Some people who have that fancy hardware can take advantage, and again, the rest of us cannot. And some of the software, some of the profiling software requires that, even to this day, like the AutoFD, OFERT, and a few others, they use a perf mode to generate traces that only works if you have branch retirement or branch recording facilities and hardware, which is unfortunate. I have some fairly modern machines and no go. So it's just a bummer. Then you have a problem of each of these tools has its own favorite data format. And as you know from XKCD, we have 16 different formats, and they're all different and incompatible. And each tool has its own favorite to produce and consume, and there's no, or there's some actually, but not very much interoperation or conversion out there. There's some examples, but a lot of the profiling data formats are very binary bound, meaning that the data has hard-coded or has in it binary addresses, runtime binary addresses, or if you're lucky, they might be mapped to like load address, symbol table addresses. But still, they're extremely bound to one particular binary that was used to run to generate that profile. That data does not teleport or apply to anyone else. It does not apply to another build with the same binary. Certainly not another build of your next version of source up, or a differently or recompiled with a different compiler or in a different architecture. All that data is bound to this particular build and never usable again. It's such a shame, right? Then to use them, even assuming you have the ability to use this data, you need to like twist the arms of the compiler or the other tools to please accept this data. You need to add, I didn't want to horrify you today and actually list like the command line options, GCC needs or LLVM needs to please take profiling data from this very file for this next job. It's like, and it's not even something that's at the configuration level or a one-time thing. It's like every C flag that you need to kind of pass these flags to over and over again, which means you have to be familiar with the build system of each package that you want to optimize this way. So some packages manage to do this, and some go so far. I'm amazed to hear this, but there are some packages, even with the distros I'm keenly attached to, where they actually do real profile-guided optimizations during a normal build process for distribution binary. So I think one of our either Golang or LLVM, one of the tool chains we ship in Red Hat or Fedora, actually do profile run. They take that profile and recompile the compiler again with that data to optimize itself twice. And my hat is off again because it is so intricate work. And it is valuable to them, and it's intricate, and it's totally unreasonable to expect anyone to do that for a normal package. It's neat that it's possible, but it's not applicable. All right. So what can we do? I'd like to review a little project by my good friend Will Cohen, who's was on my team until at Red Hat for many years. He prototyped a gadget called Sediment. I'm not sure whether he ever gave a talk about it here over the years. It is a small package. It's open sourced. It's at a prototype stage, more or less. And it basically implements a piece of an algorithm from a paper literally from 1990, so it's a long time ago, that did one very particular kind of optimization, profile-driven optimization. It was a patented algorithm, apparently, so that explains why it wasn't used anywhere else for whatever the patent length is in the US, 20 or 30 years. Thankfully, that's now out. So Will went ahead and implemented a version of this in Python, and he focused on one very particular optimization. It was how to take a binary that had separately compiled, function bodies that were separable, so usually compiled into separate sections, and then how to find an ordering of those functions in such a way that it minimizes iCache or TLB misses as the processor needs to run from function to function. So it's a very, very specific little optimization. And it operates right at the linker level only, although the HP paper had even more ambitious, wacky stuff that some other current day projects do. But I'm just focusing on this part. So the gist of this algorithm is that it collects information about the dynamic call graph of a program and makes the heuristic inference that if function A calls function B a lot, then you want to put function B's body close to function A, so they have a chance that they're on the same page or the same TLB page, or even maybe the same iCache if your iCache is large enough and the functions are small. So physical locality being encouraged by profile data. So it's a very intuitive thing to do if you know about iCaches, right? And it's so intuitive that it's a 35-year-old idea. And yet it's still not done automatically anywhere, as far as I know. But maybe we can make some progress on this at last. So the prototype happened to use a funky text format. It's called DOT. It's for actually making general purpose graphs. It's, again, an decades old tool, really cool for making graph layouts and stuff. So it converts a perf data stream to a dot graph, and then it then converts the dot graph onto a GNU LD section ordering linker script fragment. Sorry about the noun phrase, but that's it. It sounds kind of crazy and clumsy because it kind of is. It's asking this tool to produce a partial linker script which enumerates which sections of the input to put in which order in the output, because those sections are hoped to contain functions that we know call each other frequently. So there's already a weird level of indirection there, and then another level of indirection to try to phrase it in a form that LD respects this. And anyway, it's a bit crazy, but that's what we had to deal with because that's all that the tools support. Sorry about that. And to get BUtil's LD to trigger this information, to consume it, it required, again, funky command line manipulations, partly because this converted, you don't want to know. Trust me, you don't want to know. The good parts are that Will went so far as to profile a bunch of these major Fedora applications. Python interpreter, Postgres, you might have, yeah. I don't have a illustrative for this slide as to how many things he profiled. There were about 4 or 5 major and minor-ish packages. And even on those, even with the very clumsy tooling, there, he found some cases where it was routinely giving 1 to 15% runtime performance improvement, which is pretty bloody amazing. We don't throw away potential like that in compilers or normally. So again, why aren't we doing this already? And again, it's because it's so incredibly hard to integrate into the build workflow of all these packages. This particular one was based on tweaking the RPM macros that are used by the RPM build system to generate a temporary file, put it in the /temp directory somewhere, then that /temp would have to be copied and then named in the, you don't want to know. But again, he was working with the technology of the day, 2014, and working within the feature limitations of that. Anyway, so switching over to why isn't that applicable to many other programs? Think of it, and I try to think of it as a distro builder, someone who has software to build, probably automated en masse, and they're not the developers. They don't run profiles of the tools because they don't know how. There's no profiling standard thing in the build system anyway. They're worried about building as optimized as possible. This package on all the supported architectures, respinning it automatically or manually as needed. They don't want to mess with how exactly to make it set up for this particular package. They don't want to rewrite make files, right? And there's no place where they could get the profiling data from anyway, even if they could or even if they don't want to profile, which they can't, there's no way for them to get profile data from somewhere else and then apply that. Even if the tools could consume it easily, there's no source for them. But if we can make it easy for distros to accept this, then I think they will be happy, and I think it will be get over the activation energy needed to make this more popular. So if we can make distro builders happy, then I think we can make normal developers a bit happier too, because if it's simple enough for distro people to use, then it's simple enough for everyone else to use too. That's the hope. But yeah, I respect a lot of distros. I mean, I work on one too, but they have such different constraints from someone who's like a full-time kernel engineer or a full-time compiler engineer. These guys build all the binaries we run on our phones or laptops or whatever, and they want what's generally best for everyone, but they cannot go into depth. They cannot micromanage. So let's make it non-necessary for them to do so. So here is the idea so far. And I will apologize now, and I'll apologize later for, you'll see why. ProfileDB concept, I'll call it just a concept. I cannot claim originality on this, I do not. I hear there were a few other efforts vaguely inspired by the same problem space. But this is mine, and I hope to complete it enough to make it a practical option. So here's the concept. Developers and users will hopefully as easily as possible run binaries that they have lying around, run on their favorite workloads, whether it's some guy running a GNOME picture editor and just happening to run a profiler out that is already there, like sysprof or something. Just run it for themselves, then share that profiling data through our tool that we provide, and that's it. That's all they need to do. They take profiles of their favorite applications and share it to the system. In the middle is the system, the main workhorse, which is, it'll be so simple. You'll see in such a second. It's almost embarrassing to call it a system because there's not that much needed there. But it is a place which can collect profiles. It can aggregate them because we hope that there'll be many people who will want to run their own workload, and then Probit will be donating their data to this system. So we'll be aggregating them, standardizing them, and then running consensus algorithms to generate a overall profile for each of the families of binaries that we're aware of. And then the idea is that the consensus data with results would be distributed as basically a tarball, just like any other, like a TZ data, a dead tarball that can be then used by everyone else. Distro builders would be taking this tarball, put it in their build root, and then use slightly modified tool chains, which I'll tell you in a sec, to pull in this data that's now just an ordinary piece of dead data, just basically a bunch of text, and then produce as optimized binary as it can from that by, right. So there are a couple of non-obvious things in there, but it's kind of intuitive, right? So profile will be submitted to a central place. The central place will massage and unify the data, distribute the results as a tarball. Distros can take that tarball, put it in their build root, and then the tools will find the data there and optimize accordingly, automatically. That's the dream. I have a dream. I have 10 more minutes. This will work. So going one level deeper into how I envision this type of working, the developer will run their normal profilers. I even enjoy using basic old gprof because I'm a masochist. Then they would run a tool called profiledb-submit, which exists-ish. It will take the binary that you've run a profile against, your profile data. It will canonicalize it a little bit. It'll download debug info for it if needed because it needs to map addresses to symbols, so it needs debug info. Luckily, we have debug info D for the win for easy access to that these days. And then submit the combined data to a Git tree. We're using Git as the repository for this because I love Git. And textual data sits very nicely in Git. In the middle is this profiledb consensus thingy. It is nothing but a Git repo that has pushed into it all these slightly canonicalized profile streams. There's a naming convention that we would use to make sure that the profiles, when someone submits a push request or whatever, the profiles will not conflict with each other. They're kept apart by naming conventions and branch naming conventions so that they will fit together nicely. And then it's another script on this central machine will periodically run and refresh the consensus calculation. So it'll take all the profiles, generate the average overall profile that we think would make sense. And then that will become a tarball periodically released like anything else, and it will go into some standard location. I humbly recommend user share profiledb or nothing. The distro builder would need to do just this. Include the data in the build root, include, for now, I'm focusing on the GNU binutils, include a newer version of binutils for the linker to do the automatic search in this directory structure for the profile, and add those things to the C flags and LD flags. And if you notice, there's nothing there that's hard-coded in terms of function name, directory name, or anything else. These are very generic names, like the %name and %version are just RPM macros for what package we're building right now. So it's very generic, minimal, something that's easily put into a spec file at the configure step, no makefile micromanagement. Okay. So what's in the middle, this is where the concept become more precise. I'm envisioning the central part to use the LLVM sample profile text format. I don't know, are any of you familiar with that at all? Well, fix that, okay? No, Jan showed some examples of that yesterday morning. It's a very simple textual format where there's a function name, line numbers, and outgoing call graphs are shown by the outgoing function name with a number as to how many times this function calls that function. It's a very simple textual format. And it's understood already by LLVM natively. LLVM tools generated, they manipulate them, they can do aggregation already. So I just want to reuse all the tools. I don't want to write any code. The nice thing that it's source level, it's function name, line number level, so that those statistics generally tend to apply to different builds of the same software or even slightly varying versions of the same software. So there's an assumption, but of applicability that's relatively broad. So it's a nice general format. It will most likely do. And then store these documents in Git. We give a naming, we give a package a name that has the overall name and a major version number of the package. That's one level that we need to kind of group all the data with. This way, everyone who submits a GCC 15 profile will get them together for aggregation purposes. And within an aggregation, like if you have a binutils build, binutils builds like 20 different binaries, they all need their own separate profile, right? So there'll be a first level of discrimination will be a package overall name. Second level will be which binary within that package is being built. So there's some naming conventions needed. This is the part where I have to apologize because I've been working on this on and off for a couple of months, but not intensely enough to show you it today. I apologize. I have about half of this working. The reason I'm still enthusiastic is because this is really already known to work in practice, because the sediment stuff already proves this exact optimization is useful. And this is just a way of structuring this optimization in a way that the middle part is reusable and shareable. The bottom part is just the same linker logic that already exists. It's just now wrapped up in by symbol name references instead of section name references, so a little more cozy. But all the code is going to be GPL'd, of course, up on sourceware with the database and tooling and everything up very shortly. I just need to get off my butt and go home and do it. But yes, I was hoping I would have a demo for you today. I didn't. A bunch of open questions still remain. I really want to talk with Jan and other profiling experts to see, just to sanity check this idea. It's at the point where it should show results within a couple of weeks, but there's not much code. There's not so much code that it can't just be redone with a different data format, for example, in the middle. So if these experts come with a different proposal, I'm happy to change direction. That the main contribution of the idea is that we want to share profiles somewhere, and we want the build system to really easily find it and use it. Those two are, I think, the real missing parts of the ecosystem, and I'd love to just write the glue to make this work for them, but I'm not too picky as to which exact format to use, right? But Anyway, I think we need the glue. This could be one glue, and we should see it workable within, I hope, a couple of weeks, maybe months. I don't know. If it's too long, my boss will beat me up. And that's that. I'd love questions.
Is it possible?
It's okay.
Well, is it possible to actually run this profiledb for organization-wide instead of having this global GitHub thing that tells everyone how to run my code
Of
in my
course.
machine?
Yeah, I mean, the whole idea of little baby scripts and just Git. Git is not GitHub. Git is not sourceware.
No, I understand.
You run it
But
wherever you want.
By the slides, I understand this was meant to be a centralized thing for distribution.
But it can be centralized at your level. It can be centralized for your organization's build system. It doesn't have to be public.
Okay.
Right? Same thing as with our debug infod thing. It's all federated. You share it if you want. You don't share it if you want. Right? The same technology will work. Okay. And again, all the code itself will be GPL, and you're welcome to use it and change it, etc.
Is there any reason why you are using LLVM prof format here? Because the thing is like the debug information that we are going to use, right? Like we're going to have discriminators which are provided by GCC that may not be compatible with LLVM tools. And the other thing is like if you use gcob, right? Like I know that you are mostly interested in code layout optimization, but you might want to do the other optimizations also that AutoFDO can do. So if a tool can use the gcob format.
I think one of the cool things from yesterday's talk with Bayan was that he had a tool that I think was gcov_dump. I think it's part of AutoFDO, which converts.
It's AutoFDO tools.
Exactly.
Yeah.
And it converts the gcov format directly into LLVM. This exact format, or very, 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 very close. And you mentioned discriminators, which are a special notation to identify like inlining opportunities and whatever. You're right that part is not really transferable between compilers. So again, I haven't worked all of the issues out, but for that one, I would imagine just omitting that part from the canonical set from the intake to this. So basically, just reduce the information to the abstract call graph, histogram information about line hits and so on, but omit the discriminator. So it will sacrifice some optimization opportunity, but there could be enough there that the compiler could still, the compiler could be a client of this in the future. That's what where is it? So this stuff. So it doesn't have to be something that's so specialized for this particular link time reordering optimization. We could have a data set that's also useful for compile time optimization, just maybe not as well as if it was pure LLVM. Or another option could be, sure, make it pure LLVM, and then your organization knows that you have LLVM formatted data, and that's the tooling you want, and then we don't strip the information. You keep it for yourself, and you take full advantage. That could work too.
Thank you.
Anyone else? Please, please.
Hi, Frank.
Yeah.
Sorry, maybe I haven't understood. So you know that different distros have, like they start from a base and then they have like patches on top of
Yes.
them. So I'm wondering how it will be able, this setup which you propose, to match, let's say, your particular, let's say, version of the tools with the profile data stored in the DB?
I think the quick answer is no. And I think the longer answer is that no, but it probably doesn't have to.
Yeah.
So as long as the patches are not such that they drastically change the shape of the call graph, it's okay to have some noise in there. It's okay we'll be calculating consensus anyway, like a weighted average of all these things that people have contributed, which will be slightly different versions, with slightly different builds. The idea is that if we have a lot of submissions, crossing all my fingers, if over time we get a lot of submissions, and I could imagine automating the data gathering process too at some point, right? So we could get an automated stream. But once it happens, we'll take averages, and it won't be a perfect match for your binary, but so be it. It'll still be better than the default one function in the exact order that the compiler spit it out. Okay?
I have a follow-up on that one.
No.
So when you average...
We're out of time.
Oh, okay, I'm leaving.
No, okay.
When you do the consensus and you average the various profiles, right? Depending on how you use the tool, you might get a profile that shows you one thing and a profile that shows you an opposite way. You are losing maybe some opportunity for optimization if you average things out, or things can cancel each other. Have you
It's a
observed
possibility.
any of that? Okay.
Yeah, it's definitely a possibility. I'm not sure how to prevent that.
I was asking.
It could be that maybe you just keep the input data set very clean in the unoptimized form, or you grin and bear it and you just crowd out bad data with good data. I'm not sure.
I can see here a new tool which will do, this kind of average between all kinds of inputs. Yeah, because it's tricky.
It's tricky. Oh, there's one more. No, it's too late. Okay.
In the same, I guess, vein of as what Elena was saying, I was thinking about maybe adding some versioning, like a version number to the, a version number idea to the profile for the version of the tool, version plus patch, whatever. It should be, version of the program, it should be applied to. Yeah, you had already a version number thing.
Oh, I don't show it here.
In the like GCC 15 something.
Yeah, no, there's a second one actually here. I didn't show you. So to judge the weighting factor and to perhaps use it for purposes like what you say, the initial submission process collects additional metadata about the binary. So build ID, any packaging version ELF notes that might be in there, which were added to the packaging systems of Debian and Fedora, et cetera, like 5 years ago or so. So we can actually tell at profile gathering time which versions exactly these came from, and we record that and pass that information on so that can go into a calculation. And then that will survive into the consensus as additional metadata there.
Yeah, but that version number thing I was talking about was more something logical, like at the profile DB submit time,
Okay.
The submitter will say, okay, I know that this profile is for my binary, blah, blah, which hash is that, but I would like it to be applied to this, version. I know that up to version 17, it's going to be okay, even if it changes.
Yeah, I don't see any reason why we couldn't do that. Like the idea here is that these fields are entrusted to the humans to make sense of. The tooling is not going to care about those names. So if you wish to encode that you want version 17 and up, you just call this 17 and up or 17 and down, and then you would be responsible at the distro build stage to use the same keyword or keywords to identify which consensus to apply to your tool. So it's not trying to be super smart, just trust you with the names. And in the central database, we'll have some nomenclature standards so that people don't just put in random stuff. Now we're really out of time, Elena.
No, because I've been thinking about this a while. So, like, when you debug something that has been optimized using this database, can GDB kind of pull the data, the profile data maybe, or have some, because sometimes you want to know how this thing was optimized and if the bug is due to the optimization, to the PGO itself, or I'm giving you an idea.
Yeah. Yeah.
Debugging for RPM, right?
I mean, I suppose we could add another ELF node into the final binary that said what was pulled into this binary. That's actually a good idea. Thank you, Elena. Thank you for hanging 5 minutes after. Are we good? Let's talk less in the back outside if we have any more, okay?